Learn how to do related rates. Related rates are an application of implicit differentiation They test how you can relate two different derivatives and they usually ask about distance and volume. Example: the height of a rectangle is increasing at a rate of 11 centimeters per hour, and the width of the rectangle is decreasing at a rate of 9 centimeters per hour. At a certain instant, the height is 3 centimeters and the width is 8 centimeters. What is the rate of change of the area of the rectangle at that certain instant? Let's start off with our givens. We're given that the height is 3 centimeters, the width is 8 centimeters, the change in height is 11 centimeters per hour, and the change in the width is negative 9 centimeters per hour. Now what we need to do is figure out a way to relate area and the height and the width. We can do this by using the area formula, which is width times height. And after this, we will now take the derivative of the area. And so the derivative of the area equals h times the derivative of w over the derivative of time plus w times the derivative of h with respect to time. Now we will plug in our values to get after multiplying, we get negative 27 plus 88, and so the derivative of the area of the rectangle with respect to time equals 61 centimeters per hour. Now we're going to do our second example. The area of a circle increases at a rate of 8 pi square meters per hour. At a certain instant, the area is 36 pi square meters. What is the rate of change of the circumference at that instant? Well, let's look over at our givens before we try to start solving this problem. We're given that the area is 36 pi meters squared, that the derivative of the area with respect to time is 8 pi meters squared per hour. We're trying to find what the derivative of the circumference with respect to time equals. I have r equals radius written up here for later on in the problem. So first, let's start off by finding what r equals. We'll use the area of a circle formula to figure that out, which is a equals pi r squared. Now we'll plug in 36 pi into a so we can find what r equals. Divide both sides by pi, and we get that r equals 6. Now we'll use the formula a equals pi r squared to find what dA over dt equals. So dA over dt is 2 pi r dr over dt. We will plug in 8 pi for dA over dt and 6 into r. And so 8 pi equals 12 pi dr over dt. And therefore, dr over dt equals 2 over 3 meters per hour. Now we will use this, now we will find what the formula for the circumference is. And the formula for the circumference is 2 pi r. Since we're trying to find what the derivative of the circumference is with respect to time, we will take the derivative of the circumference, which is dc over dt equals 2 pi dr over dt. Since we know what dr over dt is, we can plug that into the formula to find what the derivative of the circumference is with respect to time. And using this method, we have found that the derivative of the circumference with respect to time equals 4 pi over 3 meters per hour. Personal thoughts about related rates on the AP exam are that 1, you must know your formulas for area and volume. There is no formula sheet given on the test, so you must have all of them in your head. The second thing is that you will more than likely see this as a free response question. There were 1 or 2 questions about related rates in the multiple choice section, but a good chunk of it in the free response was all about related rates. And the next thing that they're trying to test you on in the exam is how they're wanting to test your ability to relate measurements to their rate of change.